Hello, Accelerated Algebra 2 students. I'm going to do a problem here for you that'll help you review for the test coming up later this week. First off, I think you should try this problem on your own. What I would do is hit pause right now, try the problems, and then check your answers as I go through it. So the question is, can you graph the function written in intercept form y equals -1/2 x minus 2 times x plus 8. All right, you can hit pause, and then when you're done, come back. So let's go through this. First thing I would do is I would convert the intercept form into standard form. And to do that, you need to FOIL the inside parentheses. So take the x times the x squared, x times 8, and then -2 will distribute to both pieces, and you'll get 4 terms now where the 2 middle terms will be like terms. You can add those together. So after you FOIL, you'll get your 3 terms with your trinomial. Then we have to take care of this -1/2, and I'm going to distribute the -1/2 to each item inside of the parentheses, and that'll give us our standard form. So now I converted from intercept form to standard form just through using algebra. Y equals -1/2 x squared minus 3x plus 8 is currently written in standard form. And the reason why we want it in standard form is then I can identify the a, b, and c values. Remember, a is always the number, the coefficient, in front of the x squared, so -1/2. Notice how I didn't include the x squared. We're just looking for the numbers in front of the variables. So b is -3 and c is the constant term of +8. Knowing a, b, and c, then I can go ahead and find the axis of symmetry. Now we're going to use that very special equation, opposite b over 2a. So opposite of b is going to give me +3. A times 2 will give me a -1. 3 over -1 is -3. So that's my y-intercept. I can use that y-intercept and plug it into the x value of my vertex. And then all I have to do is find the missing y. Well, to do that, we can take either form. You can take the intercept form or the standard form, whatever's more convenient for you, and plug -3 in for x. I chose to take the intercept form, and I plugged -3 in both spots for the x. I simplified, and I ended up with the equation, with the answer of y equals 12.5. So my vertex is -3, 12.5. All right, now I'm going to take and find the other 2 important pieces for graphing. The next one is the X intercepts. We'll do that one first. The X intercept is whenever the y value is equal to 0. Now again, you can pick either form you would like, intercept form or standard form, and solve for x. I think it's a lot easier to use the intercept form. However, we may require you to specifically use the standard form, which would then be doing the quadratic formula. But in this case, I decided to let y equal 0. Now, before I use the zero product property, I have to get rid of this -1/2, and to do that, I'm going to multiply both sides by the reciprocal of -2 over 1, and that'll reduce out and basically move the -1/2 over to the other side using multiplication, and then 0 times anything will still be 0. So we got rid of the -1/2. Now we can use what's called the zero product property, and we can set each parenthesis equal to its own 0, and then solve them individually, and that gives me the 2 x-intercepts. When x is 2 and y is 0, there's my first x-intercept. When x is -8 and y is 0, that's the next one. All right, the last piece we need before we graph is the y-intercept. And the y-intercept will always be whenever x is equal to 0. And here's a little hint. That's going to be true for any function we study in Algebra 2. Every y-intercept is whenever x is equal to 0. So you can pick any form and plug 0 back in. I decided to pick the standard form this time because it was less algebraic work. If I plug 0 into both spots where there was an x, the first two terms turn out to be 0, and all that's left over is the c value. So my y-intercept is at the spot x is 0, y is -8. All right. Finally, we're going to graph. And when I graph, I kind of pre-did some items here. You'll notice a few things. You might have to go higher on your graph, or you could change your scale. Instead of going by 1s, you could go by 2s on the y-axis. As long as you label your scales for x's and y's, you get to choose whatever you would like. So now let's graph the information that we know. Right up here, I have the axis of symmetry at -3. So I'm going to go over -3, and I'm going to make a straight line. We usually make it dotted because it's actually not part of the graph, and that is at the equation x equals -3. There's my axis of symmetry. Well, look at the vertex. We know the vertex has to go through that -3, and then in this case it goes up 12.5. So I'm going to go over -3 on that dotted line. I'm going to go up to the point where I'm at 12.5, and then I'm going to just label that the vertex. And since I already have it written here, I don't have to rewrite the point. But there's the vertex, that one little blue point. Then we have to plot the x-intercepts, and I have two of them. I've got x-intercept being at the point 2, 0. So if I go 2 to the right, up 0, there's my first x-intercept. And then the last one, the second x-intercept, is at -8. So here's -5, 6, 7, 8, 0. And then the only other thing we need is the y-intercept, and that's at this point go over 0, up 8. So over 0, up 8 gives me a point right here. I like to label that as well. Now you'll notice something. This axis of symmetry is symmetric, hence the name. Notice how many points away from the axis of symmetry the y-intercept is. It's 1, 2, 3 spots to the right of the axis of symmetry. I can quickly reflect that over and go 1, 2, 3 spots to the left. And now I have 5 key points that will allow me to draw in my parabola. We're going to make a nice smooth curve through all of those given points. And here's the equation. Y equals -1/2 x minus 2 times x plus 8, written in the intercept form. So hopefully that's a nice review. I recommend watching this video a couple times until you feel really comfortable in all of those pieces. Good luck.